All right. So in this video, we're gonna finish up the whole module actually, and it's time to actually finally look at graphing these lines on an axis. Now, hopefully it's very familiar in these sections, but I want to just go through these two and make sure that we gave them their own proper space, so to speak. So, we have a line here. We know that this is, or we should know that this is in slope-intercept form because it looks like mx plus or minus b. But actually, that's telling us that m, our slope, is 4, and b, or our y-intercept's y-coordinate, is -3. Now, here's the thing, is one of those is easy to graph, and one's going to take just a second to truly graph. Remember that we have our x and y axis, our horizontal and vertical axis, and so my y-intercept is from the origin down 1, 2, 3, my b of -3. So there's one point that's on this line. Now, then the question is, well, what is another point on this line? And that's where we learn to use the slope. Now, the slope, remember, I informally said was the rise over run, and also the slope was a fraction, and so you might be wondering where's the fraction. But don't forget that any whole number is really invisibly over 1. I mean, so you can actually just write it as over 1, but I'm kind of trying to write it like that just to show you that it's implied that just because you don't see a fraction doesn't mean there isn't one there. It's hiding. There it is. And so now I truly have a rise over run, and this is a positive slope. So what do we mean by rise over run? It means, well, from any point that you know, catch that. So I'm not starting from the origin, I'm starting from the last point that I knew. From there, I can move up 4, because that 4 in the rise, or the change in y section, is positive, so up 1, 2, 3, 4. Now I'm here. Hold your pencil down still, though, because then I need to run 1, and that's a positive 1, so you should be moving to the right. So congratulations, you've just found your second point, and I've said it only takes 2 points to form a line, but with that being said, let's keep on going and just show that the slope can be used over and over again. So from now this point that I know, I can move up 1, 2, 3, 4, and write 1. Here's another point on my graph. Not only that, I could notice that, hey, it turns out that moving up 4 and right 1 is giving the same thing as if I went down 4 and left 1. So I can go down 4 and left 1, and I could go down 4 and left 1, and so this must be a point on the graph as well. And that would be entirely your graph. Now, the other thing I want to do, again, this is kind of why we're almost done here, and we only have 2 questions here to really explore these graphs, is I want to confirm that we did this right. And here's how I'm going to do that. I'm going to plug in this point, which is the point 2, comma 5. I'm also going to plug in this point, which is -1, comma -7. And in other words, I'm going to use these 2 points to verify that I graphed it right by plugging it back in here. Let's see what I mean by that. So you don't have to do this. I just think it's a good idea to just prove that we did this right early on by showing we can go in and check some points that we made by using the intercept and then the slope afterwards. And if one of those points from the intercept and the slope that I applied multiple times afterwards isn't giving me something that works in the equation, either I messed up plugging it in or I messed up on the original graph. So it's a great way to check your work. Anyways, let's stop talking about it. Let's do it. So the y value is 5, substitute it in. Now, because we're verifying, we'll put a question mark to say, is this equal? I'm trying to be sure it is. And then 4 times the x value, 2, that corresponded with 5, or that the 5 came from, so to speak, minus 3. Now, I'm not going to spend too much time on this. I trust that you can multiply that out and get 8, subtract 3 and get 5. And actually, yes, this is indeed true. So I know I graphed this point right. And that kind of tells me all I need to know, because how did I get here? I started at my y-intercept, which I definitely knew was at -3. I applied my slope and applied my slope again. So if it's right here and I've formed this trend, I'm pretty sure it's right everywhere. But let's just be sure once and for all. by plugging in this one as well. So I should get -7 when I plug in -1. Once again, I'm not going to actually work that out. I trust you can with a calculator, but 4 times -1 is indeed -4. And -4 minus 3, again, carefully use your calculator if you need, does indeed produce -7. So this is definitely the right graph. Now, that's a pretty amazing concept that from there, we can take any one of these points and then again move up 4 and right 1 again to get a new point, or move down 4 and left 1 again to get a new point. And here's one other cool math fact. Again, we're spending a lot of time on one problem because there's so much that we're unpacking here that's important about checking your work and understanding what's going on with slope. But here's the last interesting fact. Remember how I said that moving up 4 and right 1 was equivalent to moving down 4 and left 1? Well, guess what we just said that you might not have ever realized? Isn't it true that if I were to move down 4 and left 1, that double negating produces a positive? Well, wait a minute. What does this line have? A positive slope, because from left to right, it is increasing. Whoops. And guess what? You can form positive slopes from double negated motion. Down is a negative motion, left is a negative motion. If you do down and left, you just double negated and graphed a positive slope. Hopefully that's a cool mind-melting fact. Maybe rewind that, play it back on your own time just to really solidify how cool that was, if you don't believe me, because it's cool. Or maybe I just have to tell myself that. But anyways, let's do the next one. So this next one should go by a lot more quickly, and also our slope isn't implied, so to speak, it's literally explicitly there. So we have a slope of -3/2. Now that is maybe the one last thing to explicitly state is usually a mathematician will say if there's a negative in front of the fraction, it is mostly attributed to the numerator. But what we're about to see based on this logic is that it doesn't matter where, but it should only count for 1. Anyways, what do I mean by that? My y-intercept's 5, so from the origin, we're going to go up 1, 2, 3, 4, 5. And then from this point, I'm going to use my slope. Now this time my slope starts with a -3, so from the point I knew I will move down 3, down 1, 2, 3. And then from there I will run right 2, because that's a +2. And so look at that, moving down 3 and right 2 does give you a negative slope. Once again, we can go down 3 and right 2 again. We can go down 3 and right 2 again. And we've kind of run out of stuff to do. Also, I can't really go up 3 and left 2 because I would run out of space, but I mean, we can fill it in if we wanted to. And if I could draw a straighter line, there's my line. That's what doing the homework in the computer is for, to make sure those lines look nice. Okay, so once again, to check your work, I'm not going to this time. You should definitely plug in one of these far off points away from the y-intercept, and if one of those is right, then you definitely found the correct pattern. Now, also again, look at this. If I went up 3 and left 2, up 3 and left 2, you still get the same motion, which is a negative slope. And so just notice that a single negative in your fraction gives you a negative slope. A double negative in a fraction gives you a positive slope. Again, it doesn't matter where you attribute the negative when you see a negative out front, but just know that it can only go to one of them. Otherwise, it's not truly a negative. If you put a negative on both, you just double negate it. So when there's a negative fraction, you should mostly just put it in the numerator because that's how mathematicians really kind of view it. But the visual slope relationship that you graph works either with the negative on bottom or top. But again, just use that one as your starting place and then reverse the motion. Okay, we've got one very last short section, and there's glitter from my wonderful daughter. Um, and so we've got two last questions here, and we're just going to review some hopefully familiar words, but we're going to see them in an algebra context. Now, parallel means same slope, or it also means that two lines that never never cross. But if you think about it, and I actually kind of spoiled it, that's why the lines never cross, because they have the same slope. If they have the same slope, then they have the same rise over runs, and as long as they're kind of graphed in different places, then those two lines will never cross one another. And also, I just kind of like that parallel is a self-defining word because the L's in parallel are parallel. I don't know, that's kind of fun. Then there's perpendicular, and this one is we'll write the definition first. When lines cross, I'm going to say informally, perfectly. But what do I mean by that? What I mean is at 90-degree angles. Or rather, when they cross, they form 90-degree angles on all sides. Okay, now what does that mean our slope is between these two lines? It means negative reciprocal, which is a very fancy mathematician's way of saying negate and flip. Okay, so we just learned that parallel lines have the same slope, so if they tell you a slope, copy it. Perpendicular means you're going to cross perfectly at a 90-degree angle, which means you're not the same slope. You're whatever the slope was, but negated and flipped. Or to say it more as a mathematician, you found the negative reciprocal of your given slope. All right, well, let's just go through two examples because we've done the heavy lifting earlier in the section. And let's see what's going on here. What I want to point out, and I should point it out with the actual paper, is that this question number one is very excuse me, similar to what we did in the last question, or sorry, in the last video, in one of the earlier questions, where we have a slope of 5 passing through a certain point. So we had a slope, we had a point, we used the point slope form, and we got to y-intercept form, or slope-intercept form. So again, follow those steps. We were given a slope and a point. We then directly plugged it into the point slope form. We then turned that into the slope intercept form. And my argument here is that this question now is almost no different because I have a point and I have another line entirely, but here's the thing, I don't care about the whole line. I just care about the slope. So in other words, I'm told that m in this line is -2, and in my new line, we're going to use the same slope because that's what it means to be parallel. And so now literally this is the same as that last question. So find the equation of a line passing through this point. Well, I now have a point. I now have a slope because I'm going to copy the one that was there. Now you're probably asking, what do we do with this +3? Nothing. We don't care. All we needed to know was that there was a line that had this slope, and parallel says, great, then use that slope as well. So it feels kind of bad to leave that +3 and not really make use of it, but that's okay. I'm going a little quick here, but I am doing y minus the y value of the point I need to pass through. Again, because I want to point out again, it's the same wording now. We have a slope, we're passing through another point, and so we plug in the y and x, we use the given slope. But all I'm doing here real quickly is I'm already double negating. So it's y minus -8. I'm going to handle that right there. Equals my slope, the same slope that I was given in the other line, but that's the only thing I'm extracting from it, times x minus the given x value, which again I'm going to double negate as I plug in. All right, now technically, unless your small blue text in your homework says write in slope-intercept form, you're done here because they just said find the equation of a line. They didn't say in what form, and so even though I directly plugged this in point slope form because that's all I could really do, technically I've formed a line. Now, if your blue text kind of by the answer box says get it in slope-intercept form, then again we have to follow those last two steps where I actually distribute that slope to get rid of parentheses, which would be this, and then I subtract over that number, subtract in this case because it was positive, and now I'm in slope-intercept form if that's what they needed. Okay. We're almost done. We've got just one more example. It says determine the point slope form and slope intercept form of the line L. Now let's look carefully here. L is this line in red, which is perpendicular to y equals 4x. Now, one thing here is that they're giving us this point here, the -1, -4, so that's probably the one we're going to use. Now, also, I hate to say it, but because this line is already graphed, we actually don't need to worry about the fact that it says perpendicular. I can just look at this and get the slope. Um, let's see what that slope is. From this point to the next time it crosses cleanly, it moves down 1 and right 1, 2, 3, 4. And guess what? That means my slope is going to be the -1, the down 1, over 4. But here's the idea. What if they didn't give you the graph? Well, then take a look at how these two are related. So actually, I should do this. I should say given slope. Sorry to do that. The given slope is going to be m equals 4x. And then I'm going to write the perpendicular slope is this. Now, here's what I want to point out. Because this is, sorry, not 4x, it's just 4, but I knew 4 was my slope because it was tied to x. Remember that everything is always invisibly over 1. So what would happen if we took this fraction and flipped it? I would get 1/4 and then negate it. Well, it was positive, so now it's negative. Well, -1/4. And look, that's the same information. So because they give you the graph, they really didn't need to actually tell you anything about this blue line or that your red line is perpendicular to the given blue line. Um, but it's nice to see both of those related. So I kind of wanted to point that out first, and then I wanted to show you how do you find the negative reciprocal slope. Well, in this case, again, it was just 4, but it's invisibly over 1. I flip that and get 1/4. I then say now that needs to be negative. Remember, negative only goes in one spot in the fraction, otherwise you double negated and made a positive. Okay, we're almost done. So we have our perpendicular slope, the slope we're going to use for our red line. Now let's find out what's going on in this equation. I've got y minus, maybe I won't go as quickly here, y minus the y value that they gave me equals that perpendicular slope, the slope that I know is on the red line I'm trying to get because I can see it there visually, and then x minus the given -1 of that point that I know my graph passes through. Okay, let's work this one out. First thing we're going to do is deal with the double negation. Again, last time and the one before, I just did that as I wrote it in. Now this time, I have found the point slope form, but for the first time, it's going to look a little interesting to get the slope intercept, because when I distribute this 1/4, that part won't be too bad. -1/4 times 1 is still just -1/4 x, and -1/4 times 1 again, this time it's just not in front of x, is also still -1/4. Now, this last part, to get y truly by itself, I need to subtract 4. Here's how I'm going to write that. Oops. If I subtract 4, I'm really subtracting 4 over 1. Now, if you'll bear with me, I'm going to write it like this, which is really the same as subtracting 16 over 4. Now, what on earth am I doing there? Here's the answer. I'm getting common denominators. When I subtract this 4 over, I can't just take 1/4 and subtract 4 without a calculator unless I make common denominators. And well, 4 over 1, if I multiply this by 4 over 4, the thing I see in my other denominator, would be 16 over 4. In other words, 16 over 4 is still equal to 4, but now I've written it with my common denominator, so I'm good to do my subtraction. What would that subtraction be? It would be negative 1/4 x, and then this would be minus 17, because I've got a negative 1, and I'm subtracting 16 more, but it's over the common denominator of 4. There's my graph. And this is finally, for the quick little second here, one really important point I was hoping we would get to make, and it's this. It's that sometimes the y-intercept is not always a nice, easy point. See, if I asked you to graph this, you'd have a hard time placing that y-intercept exactly and using the slope exactly. Which is why, for in later math courses or later math topics or in higher, more difficult maths where the y-intercept isn't so nice all the time, point slope can actually be really advantageous. Even though my slope is a fraction, plugging in that individual point was really, really easy. The only reason this got hard is because my y-intercept is a fraction. I can see it is because it didn't cross perfectly. And so finding that non-perfectly crossing y-intercept can actually look pretty ugly along the way, which is why point slope can be so good. All right, that is the end of this next module, and good luck on all the rest of your assignments, and I'll see you next week for the next module.